Here we have a list of numbers, and the first question asks us to determine the mode. Now these are just words that you're going to have to remember. So mode means the number that occurs the most, and in this example that would be the number 9. The mean stands for the average. So let's say you had 3 subjects. Let's say you had English, Maths, and Geography. And let's say your marks for each of them were 70% for English, 82% for Maths, and 64% for Geography. How would you work out your average? Well, you would add them all together, and then you would divide by 3. And so the same with these, you would add all of them together, which gives us 85, and then you would divide by the total number of numbers that you can see. And in this example, we have 9 digits, or 9 numbers, and so you say 85 divided by 9, and that's going to give us an average of 9.44. The median is the number that is exactly at the halfway position. So it's the number that's right in the middle. So you might be tempted to say 18. However, the median can only be found once you have arranged the numbers from smallest to biggest, like that. And so the number that is exactly halfway, well, if we had to count from the sides, you would go one place like that, one place like that. Then you would step again, and again, and again, and again, and look what would be left with in the middle, 9. Now, how do we do this mathematically? Well, the formula mathematically is you take the number of items that you have, which is 9, you add 1, and you divide that by 2. So let's see what we get. We have 9 numbers, so we say 9 plus 1 divided by 2. So that's going to be 10 divided by 2, which is 5. So that's not the answer. What that means is you should go to position number 5. And so starting in the front, that's position number 1, 2, 3, 4, 5. And there it is. And it makes sense if you look at median. Well, you're taking the number of digits, and to the logical person, or to every person, I mean, you would take the number of digits, which is n, and most people would say that you should just divide by 2, and that would give you the halfway point. But somehow the maths just doesn't work out that way. You have to say n plus 1, and then divide that by 2. Number 4 says the lower quartile. Now, the lower quartile means that if you had to divide this data into quarters, they want the lower quarter. So for example, this number here was the halfway point, so let's ignore that. And now look to the left, we've got the numbers 4, 5, 7, and 8. Well, the halfway between those two would be somewhere over there. And then if we looked at the upper quarter, the halfway would be somewhere over there. So the lower quartile is going to be between 5 and 7. And so the number between 5 and 7 is going to have a value of 6. Now, how do we do this mathematically? Well, we use the n plus 1 again. But now, because we're doing quarters, we will divide that by 4. And so there's 9 digits. So you say 9 plus 1 divided by 4, which will give you 2.5. So you must go to the position at 2.5. And so we go 1. Let's try that again. Number 4 is position 1, so that's position 1, position 2, and then position 2.5 is going to be exactly in between 5 and 7, and so that's going to give us 6. Now to find the upper quartile, well, you're still going to use n plus 1 divided by 4, which gives us 2.5, but 2.5, that's for the first quarter. We want the third quarter, so we will times this by 3, and that'll give us 7.5. Remember, that's not the answer. What that tells us is we must go to position 7.5. So we start at number 1, 2, 3, 4, 5, 6, 7, and then 15 would be 8, so it has to be somewhere in between these two. And the number that is halfway between those two is 12.5. But if you don't know that, you just add the two numbers together, and then you divide by 2, and that'll give us 12.5. Standard deviation. Now this one you just do on the calculator, so most students use a Casio calculator, and so to do this you would do the following steps. So I know many of you use a similar Casio calculator to this one. Not all of you use the silver one, but the idea behind it is going to be the same. So the first thing you're going to want to do is put your calculator in stats mode. So you click on the button mode, and then you'll go to the 3, which stands for stat. Now some of you using a Casio calculator won't have all these other options, but that's fine, you don't need them. So you'll just click on 3, then you'll push number 1, and then you just go plug in your values. So you'll plug in the 4, and then you'll say equals, then the 5, and then you'll say equals, and then you'll go on and on until you get to 18. Once you've plugged in all your values, you then reset everything, so you can just push the AC button. You then go here to Shift, then you push the number 1, which if you see there it says Stats. Then you want to go to the number 4, which says VAR, which stands for Variance. And here's your different options. Now, standard deviation is the funny symbol at number 3. So you'll push number 3, and then you'll just say equals. And that over there is your standard deviation. It's 4.25 if we round up to 2 decimals. So number 7 says how many numbers are within one standard deviation of the mean. So what that means, excuse the pun, is, well, what we said with the average was that the average was equal to 9.44. So that is your average. Now if you add one standard deviation to that, that's going to be equal to 13.69. And if you minus one standard deviation from the mean, that's going to give you a value of 5.19. So what we have is the average of 9.44. If we add one standard deviation, then that takes us up to 13.69. And if we minus one standard deviation, then that takes us down to 5.19. So they want to know how many numbers are within that boundary. So the number 4, that's not in there. The number 5 isn't. The number 7 is. The number 8 is. The number 9, this number 9. Number 10. Then the 15 and the 18, they are too big. So how many numbers do we have there? 1, 2, 3, 4, 5. And so there are 5 numbers that are within one standard deviation of the mean. If they said 2 standard deviations, then you would add 4.25 to this number, and you would minus another 4.25 from that number, and you would make your boundary even bigger. Determine if there are any outliers. That's number 8. So an outlier is a number that is too small or too big. So it's, for example, it doesn't fit the values very nicely. For example, let's say in a class, 4 people got 57%, 61%. No, that's not going to be too big. Let's go 64% and 65%. Then there's a 5th person who got 99%. Now that's an outlier because that is just way above everything else. Or there might have been someone who got 8%. Now, we will ignore those typically, as we call those outliers, because most of the people, they get a percentage over here. And if we had to go include the 8% person or the 99% person, it's going to change the average quite dramatically. And then people might think, oh wow, that class actually got an average of 75%. Let's say we didn't use the 8%. Let's say we used the 99%. People are going to think, oh wow, that class got an average of 75%. However, that's not really true because most people got high 50s and low 60s, but then there was one person who got 99%, and that value is dragging the average up, and that's not really accurate. And so sometimes when a number is way too big or way too small, we ignore it because it's not really matching the statistics or the data very well. But now, what is too big and what is too small? Well, statistically, what mathematicians have come up with is to work out the numbers that are too small. So we call that the lower outlier. All you do is you take the value of Q1, which is your lower quartile, which we worked out in number 4, and you subtract 1.5 multiplied by the IQR. Now the IQR is the interquartile range, and what that means is Q3 minus Q1. So that's the interquartile, it's upper quartile minus the lower quartile. Now why do we use 1.5? People always ask me. Well, that's just the number that mathematicians have found works really nicely. To find the upper quartile, so not the upper quartile, the upper outlier, so this is the higher number, we use Q3 and we add 1.5 times by the IQR. So to work out the lower outlier, we will take Q1, which we got a value of 6, and we'll minus that by 1.5 times by the IQR. Now your IQR is your upper quartile, which we said was 12.5, minus your lower quartile, which is 6. And if you go plug this in on the calculator, you get a value of negative 3.75. So what that means is if there's any number that is lower than that, then that's going to be called a then any number smaller than that will be an outlier. However, our smallest number over here is 4, and so we don't have any lower outliers. I'm going to quickly calculate the upper outliers, and so that's going to be Q3, which we said was 12.5. Q3 stands for your upper quartile, plus 1.5, it's always going to be 1.5, and then we use the IQR, which is your upper quartile minus your lower quartile. And if we calculate that, we get a value of 22.25. So any number that is above that is considered a outlier, but our highest number is 18. And so what this means is that these numbers are all fairly close to each other, and we don't have any one of them being too small or too big, so none of them are outliers. Number 9 asks for the 5-number summary. The 5-number summary is the following. So it's your minimum value, your lower quartile, your median, your upper quartile, and your max. And so if we had to list those 5 numbers, well, it would be equal to, and we could show it in brackets like this. The minimum value was 4. Our lower quarter value, we said that was 6. Our median value was 9. Our upper quartile was 12.5. And our maximum value is 18. And that would be your 5-number summary. Number 10, draw a box and whisker diagram. So a box and whisker, it's a very easy concept. You take your 5-number summary and you plot that on a graph, or like almost like on a number line. So what's very important is that you make use of a ruler. And now what you do is you just go list your minimum value at the front over here. So that'll be a value of, that'll be our 4. Then we go 2 centimeters on to over here, where that'll be a value of 6. Then we go 3 places over here, so that'll be 9. And then we go another 3.5 places, so 1, 2, 3.5, so that'll be 12.5. If you have a better ruler, you can match the values. So for example, if I had a 30 centimeter ruler, I could have started by putting the 4 at the 4, but because I don't have enough space, I have to do it like this. And then the 18, well, that's going to be 5.5 places from there, so that's 1, 2, 3, 4, 5. So that's going to be right at the end. Okay, so I only have 14 centimeters to use, so I had to do it a little bit differently. But if you had a 30 centimeter ruler, you could match the numbers that you see here exactly on your ruler. Okay, then we can draw our box and whisker like that. Then the last question asks us to comment on the skewedness. Okay, so skewedness is always a weird one. All that you need to look out for is look at these 2 tails. Well, those are the whiskers, right? Because we call it a box, which is the central part, and the whisker, which is the 2 parts on the side. It's longer on the right-hand side, and so we'll just say skew to the right.